Hello everyone. This is our last class. I know some of you may be listening to this and turning in this last week assignment. That's fantastic. This is one of my favorite topics, so I'm glad to have you along for the ride. If the vast majority of you have opted out, I kind of get it. It is the last topic on the syllabus. So for this block of conversation, we're going to explain the role of operations management and the degree to which it helps organizations achieve goals of quality, efficiency, and responsiveness for customers. We're going to describe operations systems, and we're going to talk about how they differ depending on the type of organization, and also bow to the fact that some companies are product producers and others are service providers. We're going to discuss some trends in operations management and what the future holds. Now, most of that is done through the supplemental readings. My purpose with this lecture is to really tackle what I consider to be kind of a limited number of topics covered in the chapter. So again, disregard the chapter, go with this content in this lecture for some of the basics, and then the readings for this, talking about the future of operations. So, operations management, it's the management of any aspect of the production system that transports inputs into finished goods or services. And it really doesn't matter what kind of organization we're talking about here. So we could be talking about retail or wholesale, hospitals, offices, parks, national parks, and even theme parks, and hotels, and then of course manufacturing. Most people think of it as something that is just tied to manufacturing, but it's not at all. As I will often say, the most effective operations I have ever seen in my life are at Disney World. They do a better job of moving customers through there and providing them with the essentials that they need, maintaining the pace, maintaining the focus, and all the rest. It is as highly effective as anything I've ever seen. Operations is important in our discussion of management topics as this overview before you move into the rest of your graduate program, because it accounts for the most people, the largest percent of the capital investment, and most of the working capital needs. So it is the main engine that sort of drives what happens inside an organization. Do you remember this? I don't remember if we showed this exact diagram, but we talked very briefly at one point early in the semester in the strategy part about value chain, the idea of a value chain, and that organizations have what are called primary value activities that are in essence creating the product or creating the service, and the primary value activities represent those activities that are moving from inbound logistics through to the customer and all of the things that touch it in between. The support activities are the ones that sit at the top of this diagram, and that in essence are there to make sure that the primary activities have the best people, have the best R&D, have the best technology, have the best supplies, and the flow of money and legal assistance needed to ensure that the primary activities do what they're supposed to do. So it is an interdependent relationship there. Well, I like to use this to show what operations does. So operations management in virtually any organization is responsible for anything coming in, the value-added production activities themselves. Again, it may be producing a service, it may be producing an experience, and then the outgoing. So whether it's a person coming in, enjoying an experience, and then leaving, or whether it's raw materials coming in, being manufactured into something else, and then leaving, it is all of those activities each time. Okay, now let's talk about some of the responsibilities of operations managers, what they do. They're concerned, as their primary concern, generally with quality. And the reason we say quality of the experience, of the service, of the product, is the most important thing, is because everything else is derived from that. So if you have really great quality, then you can control your costs. If you have poor quality, then you tend to have cost overruns as you deal with your quality problems, right? If you have service problems with customer experiences, which again is a quality issue, then you have to deal with that. You have fallout and ramifications and extra costs associated with managing the organization. And it's all because quality is not what it should be. So quality is viewed by people in operations management as the starting point for everything else. The organizations tend to define quality in very different ways. So I like we could spend an entire day talking about all the different ways people define quality, establish quality standards, measure quality, reflect back on all those control procedures we talked about a week or so ago. So quality can be defined as reliability, meaning that something does what it's supposed to do every single time. So your service experience is the same every single time. Your interactions with your bank may be the same every time you go. Your interactions at a particular restaurant may be consistent and replicable or reliable every time. Quality also can be defined as durability, which is how long something lasts. So when we talk about Toyota or Honda, we often talk about the reliability and durability of their vehicles. So they're reliable in that they start every time and they do what they're supposed to do. You don't have quality issues with Toyotas or Hondas, in my experience and in the experience of the vast majority of people. And they last forever. You usually will park one of these vehicles and walk away from it before it will give out. They will keep running indefinitely. Also, quality could be your designed performance attributes. So some people might argue that Mercedes is a higher quality vehicle than a Toyota. Well, when they say that, there is a lot about a Mercedes that is very high quality. It's primarily its performance attributes about it. The engine itself, certainly the design, the interior aesthetic of it all. And maybe you can speak to reliability and durability there as well. And then quality in operations is also defined as conformance to specification. So often this reliability, durability, and performance attributes and other forms of quality like that are something that are a characteristic of the design itself, and by ensuring within operations that all of the work that is done conforms to the standards that have been set or conform to the specifications that have been written, that as long as you conform to those specifications, then the product or service will meet those reliability, durability, and performance guidelines that were mentioned. Management in operations is also concerned with the idea of efficiency or productivity. They care a lot about this. This is the cost effectiveness of what goes on. So if we said before that operations is responsible for most of the cost, most of the assets, most of the employees of the organization, are those costs being managed appropriately? Are you getting a full day's work out of all the employees? Are you making best use of the assets that are there? So you're concerned about whether the inputs are being utilized effectively and converted into outputs, right? That's the definition of productivity. It's the degree to which inputs are effectively converted into outputs. Sometimes it's referred to as a ratio. So it might be the number of hours of an employee's labor required to produce a unit of output. That might be a measure of productivity. And the focus in a lot of organizations is on just elimination of waste. I suspect most of you have heard of this phrase lean, the lean philosophy. Lean is a concept that came from someone who wrote a book about Toyota. The Toyota manufacturing system, it's Kanban, just in time, are all words used to describe the Toyota manufacturing system. And this particular author of a book referred to the lean philosophy that they had. And that's been picked up, kind of bundled up with Motorola's Six Sigma model that they developed. All of it rolled in together as sort of a continuous improvement philosophy inside operations and organizations as a whole, focused on eliminating waste. And it takes a lot of different forms, and that's, an entire series of conversations to talk about the lean philosophy. The third responsibility of operations managers is responsiveness to customers and making the decision how responsive is responsive enough and what kind of response is appropriate. And so it's in essence about trying to respond or take action to meet new needs of customers or specific demands of customers. It could be that you're trying to, over time, evolve your organization so you deliver things more quickly. Certainly, Amazon has demonstrated that interest in delivering things more quickly and being more responsive to customers. So, by bundling things and promising a 2-day delivery, they had already set one really high bar, and they are in some cities and moving toward getting things where they're even faster than that. So, when they get to the point where they can read my mind and have it there before I actually realize I need it, that will be what I believe is Amazon's end game. I think that's what they're trying to accomplish. And as the list shows, there are a lot of different ways to be responsive to customers. Let's talk a little bit now about the capabilities that are inside operations and how we think about those. So if we were planning new operations, or as we manage them on an ongoing basis, we tend to group the decisions into a couple of different categories. Some of the decisions are made infrequently. They are really what we might think of as strategic design decisions within operations. And then other decisions that are more ongoing routine processes of operations. And this list that I'm going through is sort of both of those things. So operations is concerned with process design and layout, and I'm going to come back and talk about that more specifically in a minute. But that is, in essence, deciding, some fundamental things like are we running an organization that is going to, or operations that are going to create wholly unique products for each customer, or create a wholly unique experience for each customer, or are we going to move large batches of customers or products, all of which are similar, experiencing a similar thing through our operations. So you might say a hospital, for example, is largely treating customers, or I guess we should say patients individually, right? They come in, they're assessed, and they then move through a process. Now, some aspects of that are routinized. Some aspects of that, as they move from one thing to the next, certainly from an operating room into recovery, there is nothing about that varies, right? That is very replicable, sort of what happens as you move from one to the other, which is why they're able to control it, why they're able to ensure the quality of it, and they do it the way they think everyone should be treated. So that's a very predictable sequence of experiences that someone would have in a hospital. A manufacturing plant could choose to take orders from individual customers and make individual items for them, like a machine shop does, or it could be something that takes an order and it produces something it's already designed and just produces 100 of them and ships them. It's not that unique. They just activate an order more than design or invent an order. We also, as part of these sort of strategic level decisions about how to organize things, we can talk in terms of facility sizes, how big. Are we going to have several small facilities distributed around a state or a region of the country, or are we going to have one large facility? An example of this is BMW. BMW has a assembly plant in South Carolina that makes a particular vehicle. I can't remember which one it is, but it's maybe even two of their BMW vehicles, and they only make those vehicles in South Carolina. So they sell to the rest of the world from that vehicle plant in South Carolina. So they have chosen to have a very specific focus, as shown here, focus on one product, and again, it may be two now, but it started out as one, in one location, but it is a huge facility. Another company may choose strategically to divide up its production, maybe have one facility in the Western Hemisphere, another facility in the Eastern Hemisphere, and to divide up the production capacity, in essence, replicate exactly what they're doing, but in two different locations, half the size, two locations, equally focused. Another auto assembly plant might choose to move 4 or 5 different vehicle models. This is highly unusual, though. Maybe 4 or 5 vehicle models through the same plant and have less of a focus. That's not typical in automotive, though. Another thing that's important is capacity, whether you're going to be a company that keeps a little excess capacity for emergencies and special orders, or are you a company that wants to run flat out so that you have distributed your cost over the maximum possible units and get your lowest possible cost. It should be clear to you that all of these decisions about the process design, the technology choices about automation and other things, the facility size, location, and focus, and the capacity, that all of these issues ultimately are tied to the strategy the firm is trying to implement. So if they're trying to achieve low cost, if you remember from that chapter, then they would align these decisions with efficiency and low cost. If, on the other hand, their strategy is one of differentiation, and they will make very, very different decisions about how to organize these decisions. And then finally, we would talk about the strategic implications of workforce capability, and then sort of the operating activity of this all, which is called supply chain management. And that is trying to understand what your customer demand is going to look like, trying to understand what sources of supply and labor you need to have in order to make that happen, and then establishing the right schedules and inventory and other things in order to pace the production of the product or the delivery of the service or the creation of the experience, depending on what it is you're trying to do. So some people don't think of supply chain management as something that a hospital is involved in, but I can guarantee you people who work in a hospital think that it's part of what they do. This is an example of a process layout. Well, I said process layout. Let me take that back, because that has a little A and a product layout. That's confusing. It is a process, but it is called the product layout. Looks like an assembly line to me. I prefer to call it an assembly line, but it's when work flows the same sequence every time. So you're going from A to B to C to D and producing something in sequence like that. And an example of this would, of course, be an automotive assembly line like we've been talking about. You could also argue a cafeteria line is this way. So if you think of each of those blue dots as a workstation, that workstation could be putting something onto a vehicle frame, or that workstation could be serving you the vegetables, and then the next is serving you the meat, and then the dessert or whatever. But the idea is you're moving in a linear fashion past all of that, getting something from each station. And that is organized in a certain fashion. And so there's a kind of a specialization of activity or food taking place at each station, and you move along it, or the vehicle moves along it, and as it moves through each stage, it adds to what it has. Another example of a process organization or a flow is a process layout. And again, I call this jumbled flow. A jumbled flow, or even a job shop. That term is used as well. But just think about what this is like. The idea here is, instead of any customer or say any product moving in a sequential linear fashion, it is moving instead uniquely. It might go from the top left corner to the top right corner and then exit. It might go from the bottom left corner, top right corner, bottom right corner, and then exit. It may be that it goes through all 4, and it could be it goes all through all 4 in a different order than what the previous customer or product experienced. Now, if you think about it, most services are this way. So if you need a service performed somewhere, if you walk into a bank, depending on what you need, you might see a loan officer first, you might have to go see somebody else first. Bank's not that complicated anymore, but you can imagine if you had other kinds of services. Like if you move to a new town and you have to get taxes figured out, and you have to get, your vehicle license and a vehicle tag and all of that. You could think of those sort of almost the random nature of where you start, what you do next, and then shift over and go to something else. Somebody else might enter and just be renewing their tag. So there are all these specialized workstations, and depending on what you need done, you move from one to the other. Waffle House is the example of a restaurant that follows this. I mean, it's a short order restaurant, meaning each order, they cook whatever it is that you've ordered, right? And so one order could look completely different from the next order, completely different from the order after that. And so the chef and all of the people that are putting your food together are moving around what might seem to be sort of randomly from the stove to something else as they prepare your food. The third and final example of a kind of a typical generic layout inside an operations or as part of operations is what's called a fixed position layout. Everybody will relate to this immediately. If we were assembling a large aircraft, the aircraft is not going to move along an assembly line like a car, and is also not going to move randomly from one station to another and then exit. In reality, everything's going to come to it. And so in that particular circumstance, we might have a period of time when certain things or certain operations are performed on the aircraft, and then we schedule the arrival of whatever the next component is to be installed. But the aircraft doesn't leave. The content of the work is scheduled to arrive at that fixed position. So would be aircraft assembly. It would be any construction project, like if you're building a house, building this building that's going in next door, right? Different things are happening at different times, and you're planning a project, in essence. Weddings are another example of a fixed position layout. Everything is being scheduled to arrive at that location. So events, construction, and big item assembly all operate under this same set of circumstances. What they all have in common is that work is grouped into it's grouped in some fashion. So, there's certain work that takes place before other work. So this idea of what comes first, what happens second, what happens third matters, right? That sequence of steps. And then it also matters whether all of the products are experiencing the same steps or certain things experience different steps. So how different are the products that are being produced? How different are the services being provided? So if you have a custom design business, it's going to look more like the green process layout. If you have a large volume, low cost commodity production operation that is assembling something, and it's just doing as much volume as it can flat out all the time, that's going to follow the blue circle product layout, right? It's a little bit of common sense. These are the extreme examples to illustrate these fundamental differences. So I'm not going to go over this in any great detail, but these slides right here summarize some of these points that I was making. So product layout is more standardized output, lends itself to automation, and it describes how the workstations are arranged. The process layout that was at the top right corner in green is usually a lower level of automation, more custom work being done. Now, it could be that each one of those green cells up there, those green boxes, represented a machine, but there's a human moving from machine to machine, making use of it, a drill, a lathe, that kind of thing, in order to complete a product at the end of that. Most services are organized in this way. So if you think of a hair salon, car repair, most retail experiences, it's a lot like what is referred to here as the process layout. That's the green box, jumbled flow, job shop model. The fixed position layout, again, is like a wedding or a conference, something that is more of an event. Or a fixed position project like a construction project. And of course that makes sense too. So operations decisions that determine capability, if you remember this list that we put up a few minutes ago, let's look at a couple of additional thoughts. So when we're talking about process design and technology, some of the things that we're seeing on the horizon R, was called mass customization. What does that mean? You know, I just got through saying that the blue assembly line model was more of the mass production, and I said the green boxes that represented jumbo flow was more of the customization, right? The unique product being provided to somebody. Well, that's always been the dilemma. Every organization would love to be able to produce more variety at lower cost, right? To combine the best of the features of the blue assembly line and the green job shop. And that's what mass customization is all about. And that is accomplished, in theory, through reprogrammable automation, right? So, you know, it used to be, and largely still is the case, that when robots are used, they kind of do the same thing over and over and over again. They just do it 24/7, unlike people, but they're repeating what a human might have done, but doing it without stressing, picking up too much weight, and all the concerns you have with a human doing heavy work. But mass customization combines, reprogrammable electronics with robotics, so that you can accomplish some of the variety that you would want from a job shop-like environment, but at the repetitive, without setup time, without learning and all the rest that you would get from a robot. So there are a lot of new technologies helping out with that. There's a lot more data available for figuring out how to organize these things. You can do things at much smaller scale and begin to disaggregate. Some of what we're seeing with mass customization is also use of what's called, depending on who you ask, additive manufacturing, or it's also called rapid prototyping. It's also called desktop printing. And back in the old days, it was called stereolithography. So all of those terms refer to largely a common set of technologies that are associated with, rather than taking a piece of metal and cutting out from it to get it what you want, it would be the equivalent of building it layer by layer, from nothing up to something, rather than taking something bigger and drilling down to get something smaller. And so that idea is one, again, is reprogrammable automation that would allow mass customization. A lot of gains made, even in the last 5 years. The technology's been around for 35 or so, but it was laboratory-based and prototype-based until just recently. Now it's beginning to get a lot more legitimate as an actual production technology. We're also seeing pressures in terms of workforce capability. So, looking down this list of issues in operations, workforce capability is an important one, and that means that as we have fewer and fewer jobs for people that involve, low skills, we're developing more and more jobs that involve high-level skills. And that's great for the most part, because we have so many more people that graduate from high school now, so many more people that graduate from college now on a percentage basis as well as a total number basis than ever before in the history of the country. So, but it is the case that those numbers keep going up. We need more and more skilled people, and there are significant labor shortages now. Whenever we're lacking in capability and have labor shortages, there will always be pressure, counter pressure to automate then, to remove that as a form of vulnerability, and we're seeing that. We'll see how all of that shakes out. And then in terms of supply chain management, we're seeing a tension created between sort of what are called global supply chains, meaning people sourcing from all over the world to bring it here to be assembled and sold here, to more and more concern about the environmental issues associated with that. That all of that fuel use, all of that transportation, it makes sense if that's the way things have to be. You want to be as efficient as you possibly can, but there's tremendous pressure to try to do more local sourcing and to not have so much of a carbon footprint associated with things. And so that concern about global supply chain sustainability and risk is a very real one, and that's one thing that is top of the mind for operations managers. So for those who are in operations management, this right column of topics is one that keep them awake at night, trying to figure out what might happen next. I wanted to spend just 2 seconds closing with the idea of why manufacturing matters. There is a tendency, I think, for people to think that the U.S. is no longer a manufacturing powerhouse, and of course that's a misunderstanding. We have far fewer people employed in manufacturing than we once did, just like we have far fewer people employed in agriculture than we once did, and far fewer people needed in either of those activities. Most of our economy now is employed in services. But the reason manufacturing matters is the same reason agriculture matters. The one thing we can say about agriculture, we still produce enough to feed ourselves and then some in the U.S. So just because we don't employ as many people does not mean we don't still have that capability within the country. We have become infinitely more productive and therefore with that much higher level of productivity, we are able to reduce the numbers of people involved, but still maintain exceptional levels of output. Well, that's true also in manufacturing. So even though manufacturing employment has plummeted, manufacturing output has not. And that's a misunderstanding about the U.S. economy. But it is the case that there has been a lot of outsourcing that has taken place, usually in areas that are highly labor-intensive, low-skill areas. And some of those things are coming back to the U.S. because automation is allowing them to come back to the U.S. And we'll see more of that, to be honest with you. There's a lot of argument that the U.S. will be an even stronger manufacturing power than it is, and it's extraordinary now in the not too distant future. And that's because for a long time now, automation has been improving and getting so much better in its capability, not just its efficiency, but its capability that that opportunity exists. So manufacturing plays a significant role in world economies. It is generally the case that 70% of exports that occur from any country are in manufacturing related areas. Manufacturers account for up to 90% of business R&D spending. This is hugely important. If I had to pick the one thing that would say we need to be a manufacturing powerhouse, it's this. It's because it's so closely tied to R&D investment. And R&D investment and the innovations that come from it are a key to national competitiveness. And so those two things go hand in hand. It has been the source of exceptional growth in productivity. Exceptional growth in productivity. Historically, as nations develop, the manufacturing share of that nation's gross domestic product, meaning what it produces inside the walls of the country, it peaks at 20 to 35%, and then growth shifts to services. And if they have a strong service economy, the percent of GDP allocated to manufacturing will go down below 20, 35%. Manufacturing accounted for 25% of U.S. jobs in 1950 and only 9% of U.S. jobs now. Less than 10% of U.S. jobs now. But this only goes through 2010, and I'm showing you something from 2010 for a reason. This is similar to, I can't remember if I showed you this before, just something that shows the same stuff. But remember when we looked at some of the figures that were from the Enlightenment Now book. This document that I'm showing preceded Enlightenment Now by, years. But this was published in about 2012, I think. And it's talking about large developing economies moving up in global manufacturing. And so you can see here that the United States in 1980, 1990, 2000, and 2010 was the largest manufacturer in the world. So even at a time when people were claiming we were not a powerhouse manufacturer, we were a powerhouse manufacturer. The thing they were keying on is the number of things that had been outsourced, and there were a lot, and the decline in employment, but not in terms of what's produced here and sold. It's just produced here much more efficiently than it once was. And let's be candid, if it had not been produced more efficiently, it would not have survived. That's the way economics works. So what's interesting on this, first off, is the degree to which South Korea, because all of you talked about South Korea before, has gone up over and over again in this list. From South Korea was 11, and then they were 8, and then they were 7 in 2010. It's also interesting to notice what's happened with China. China improving from 7 to 4 to 2. And I will say that starting about 2011-12, China did surpass the United States in manufacturing gross value added. Okay, they are a bigger manufacturing economy than the United States. But just like the United States, the number of employees attached to manufacturing has gone down because of improvements in productivity. This is another illustration, again talking about manufacturing output. It just came a little further forward in time, 2014, showing the U.S. just right behind China in terms of manufacturing output and how the other countries line up with that going out. Now, there is many different ways to calculate manufacturing output as there are ways to present them, and so there's things that are value added. Look at manufacturing value added, which just means you subtract the supplies that come into it. It's just if supplies were imported from somewhere else, and it is the case the rankings stay the same. I've seen those numbers too. I just don't have them in a graph. I have them in a table, and they don't look quite as good. So I just want to make this point to you, and make the point to you that manufacturing in the U.S. is strong, regardless of what you hear. Particular industries suffer. Particular industries suffer because if you're talking about, some industries aren't viable long term, and some industries need to make investments in technology to be more productive. And when they don't, like textiles and apparel, they tend to be shipped offshore where things can be produced more cost effectively. And that's because they did not make investments in technology to move toward automation. So the jobs would have been lost either way. The jobs in low-skill manufacturing would have been lost anyway. I don't want to gloss over that, but the production capacity would have stayed here if the companies had made investments in technology. And we're seeing companies catch up with all of that now and address some of those issues. I think there's a real awareness of all of that. And a lot of companies that have always been exceptionally committed to making those kinds of investments. Okay, this wraps it up. So I hope that gave you a little bit of an overview of operations management, what their primary concerns are, what the sort of decision areas are that they tend to address over time, and what some leading trends are that will be changing the nature of operations going forward. Okay, this is the end of the course. I hope you've enjoyed it. I think taking it online is a very different experience from being in class discussing it. I wish I could have had conversations with all of you about these topics, and good luck in your academic program.